Have you ever really stopped and wondered what's holding your car together? I mean, we see the paint, the nice interior, but underneath all of that, there's a super complex, highly engineered skeleton. And it's the result of like a 100-year-long technological battle. So today we're going to peel back the skin and take a good look at that skeleton underneath.
It seems like a pretty basic question, right? But to really get a grip on the skeleton, we kind of have to understand the whole animal first. So when you strip it all away, what is a car really?
Well, if you're an engineer, a car is really just a collection of systems. You've got your engine, your suspension, the wheels, all the electronics. And every single one of those things adds to the total weight. But as you can see, one slice of that pie is way bigger than any other. And that's what we're focusing on today. Yep, a full 20%. The single heaviest part of your car is its structural frame. It's what engineers call the body in white. Think of it as the hidden skeleton that literally everything else bolts onto. And its story is actually pretty fascinating. So here's our roadmap. First, we'll get properly introduced to this body in white. Then we'll jump back in time to see how steel completely took over the auto industry. After that, we'll look at the big problems that forced a century of nonstop innovation. We'll see how that led to the super complex hybrid bodies we have today. And finally, we'll take a peek at what's just around the corner.
All right, let's dive in and meet the star of our show, the body in white, or BIW for short. The name might sound a little weird, but its job is absolutely critical.
So the term body in white actually comes from the factory floor. It's the stage before the body gets its primer and paint, and it is, quite simply, the car's skeleton. It's the core structure that gives the car all its strength, all its rigidity, and most importantly, it forms the safety cell that's designed to protect you in a crash. Now, what you're seeing here, which is just so cool, is that the BIW isn't one giant piece. It's actually this intricate puzzle made of hundreds of different stamped metal parts. You've got floors, pillars, rails, all of it welded, glued, and fastened together to create one single, incredibly strong shell. So how did we get to this point? I mean, why is this skeleton almost always made out of steel? To answer that, we have to go all the way back to the dawn of mass production, where this massive engineering shift happened that changed everything. See, in the early days, cars were built like the one you see on the right, a big, heavy, separate ladder-frame chassis with a body just bolted right on top. But the real game changer was the move to the unitary body on the left, which really took off back in the 1930s. This image really shows you the shift. By making the body and the frame into one single piece, the car suddenly became lighter, stronger, and way more rigid, all at the same time. And here's the key. This new design was perfect for the assembly line. It could be mass-produced using giant stamping presses and simple spot welds. And that's what made cheap, low-carbon steel the undisputed king of the auto industry for decades. Okay, so steel is king. But, it wasn't all smooth sailing. Just as steel was getting comfortable on its throne, a whole bunch of new problems started popping up. And these challenges kicked off this technological tug-of-war that forced engineers to basically reinvent the car body over and over again. The first big enemy? Rust. And I mean bad rust. By the 1960s and 70s, especially in places with wet or salty winters, cars made from plain old steel were just corroding away. And this wasn't just about looks. It was a huge safety problem because the car's skeleton was literally dissolving.
So the industry fought back, and they fought back hard. Steelmakers came up with zinc-coated or galvanized steels that were way more resistant to rust. Car makers poured money into incredible new painting systems that used electricity to bond primer into every single nook and cranny. And these changes worked so well that car warranties against rust jumped from maybe a year or two all the way up to 12 years or more.
So they beat the rust monster, but then a whole new crisis hits, the 1973 oil crisis. All of a sudden, gas was expensive and it was hard to get. This led to the very first fuel economy laws, and the message from the government was crystal clear. You have to make cars lighter and way more efficient. And where did the answer come from? Well, believe it or not, from the steel mills themselves. Engineers started cooking up all these new recipes for steel, creating alloys that were much, much stronger than the old stuff. And because this new high-strength steel was so tough, they could use thinner sheets of it to build the car's parts. Thinner steel meant less weight, and less weight meant better mileage. Problem solved. Okay, next up on the list, safety. As crash testing and safety ratings became a really big deal, the public started demanding cars that could actually protect you in a serious crash. And that old, simple steel skeleton just wasn't going to cut it anymore. So what did engineers do? They created a whole family of smart steels. For the passenger safety cell, that's the cage that protects you, they used these unbelievably rigid, ultra-high-strength steels.
some of which are hardened like a knight's armor. But for the front and back of the car, they used softer steels designed to crumple up on purpose to absorb the energy of an impact. The skeleton wasn't just a frame anymore. It was now an active safety system.
Now here's where it all comes together, and it's really, really cool. All those different solutions, for rust, for weight, for safety, they didn't replace each other. They all got layered together, creating the incredibly complex car body that we have today.
And this is what you get. This is the result of that whole century of evolution. A modern car body isn't just made of steel. It's a hybrid. It's a carefully engineered cocktail of a dozen or more different grades of steel. And every single color you see on this diagram represents a different type of steel, picked for a very specific job. This table just breaks it down perfectly. Think about it. The roof needs to resist dents from, say, hail, so it uses a special steel that actually gets stronger inside the paint-curing oven. The beams inside the door have to resist the side impact, so they're made from ultra-high-strength steel. The rails at the front need to crumple and absorb energy in a crash, so they use a totally different kind of steel for that. It's the right material in the right place every single time. So where does the story go from here? Well, just like the oil crisis back in the 70s, there's a new energy revolution that's forcing another massive change in car design, and this time it is all about the batteries. Electric vehicles are fantastic for emissions, but man, they create a huge weight problem. A typical EV battery pack can weigh half a ton, sometimes even more. So to make sure the car can still get a decent driving range, every other part of the car, especially our skeleton, the body in white, has to go on a serious diet.
And this is the new frontier that car designers are exploring right now. They are pushing for even lighter, even stronger steels, they're using way more aluminum and magnesium, and they're even trying to figure out how to mass-produce parts from super exotic materials like carbon fiber. The car's skeleton is evolving once again right before our eyes.
Which brings us to the big final question. For 100 years, steel has been king because it was always able to adapt and solve the next big problem. But now, with the incredible weight of EV batteries, the car's skeleton is facing its biggest challenge ever. So, will the future be built from advanced steel, lightweight aluminum, or is some brand new material going to come along and become the new king? The race is definitely on.